This is the problem on the passive solar house, and it says, in the passive solar house, the sun heats water stored in barrels to a temperature of 38 degrees Celsius. The stored energy is then used to heat the house on cloudy days. Suppose that 240 million joules of heat is needed to maintain the inside of the house at 21 degrees Celsius. How many barrels, 1 barrel equals 0.16 cubic meters of water, are needed? So here I took a couple of images of the internet, and let's see what shows here. This is kind of original passive solar house. There's no water in here, and the winter sun, as it says here, would heat the inside of that room, and then actually you would have pretty good heavy rock here, massive rock that would then absorb that heat from the winter sun and then could give it to the rest of the house, respectively radiated out here and radiated back into this particular room. In the summer, with the sun standing higher, it's not directly shining in, but I've been in a house like that, and it's pretty hot in the summer, this particular room, and in the winter it has a really nice temperature. Anyway, that's what it is, and then the way to describe it here is this particular one here with the water. That's one way of doing it. So the heat reaches this one here, and then there's an antifreeze fluid in here. So as I said, this is one other technique. Neither one of them is exactly the same they're talking about here in the problem. So there's an antifreeze in here, and then there's a pump, and it goes into the water tank here, which then heats the water. Either way is kind of considered passive solar heating, as contrasted to the active solar house, which would be photovoltaics, but there's not it. So we're heating water here. So let's see what's given in the problem. They tell us what the heat flow is. So Q is given. They tell us what the temperature difference is. It's 17 Celsius degrees, and what it means is that the water does heat up to 38 degrees Celsius, but then gives off its heat to the rest of the house, maintaining it at 21 degrees Celsius, including the water itself. So that's why the temperature of the water itself goes down to 21 degrees Celsius. And of course, it says it's maintaining, it's actually not increasing its temperature because the house is losing heat to the outside anyway. So we're kind of looking at a winter house here. Of course, if the outside temperature is 35 degrees Celsius, we don't want to have any heating going on anyway, and we'd be rather using the air conditioner than trying to heat the house. But so this one must be like in the fall or spring or winter, where the outside temperature is lower, so we're losing heat to the outside, and therefore we need to heat it, and that's done with this solar passive heating. Okay, so delta T is given. The mass of the water is not given. However, they want to know the volume, and the volume, of course, is linked to the mass by the density of the water. So that's why we come up with here a question mark for the mass, and once we figure out what the mass is, we can figure out what the volume is of the water. They ask us to figure it out in barrels, but we calculate it first into cubic meters, and then we convert it to barrels. And then, of course, the specific heat capacity of the water is given, and considering these variables here, the algebra is going to be straightforward. Respectively, there really isn't any algebra. We just write down the equation for specific heat. So Q equals C times M times delta T, and then we're supposed to figure out what M is. So mass equals energy divided by C and delta T. And then, yeah, we don't have to figure out what the mass is, or figure out first, but we have to figure out what the volume is. So mass equals density times volume. So actually here, volume, therefore, when I substitute that, density times volume for the mass, and then divide by the density. I'm going to come up with this one here, Q divided by density, specific heat capacity, and delta T. This one here being the incredible 240 million joules, the density 1,000 kilograms per cubic meter, the specific heat capacity 4,186. Notice that this is a huge number, but these two are relatively large as well, in the thousands each of them. And then the delta T, that would be the 17 Celsius degrees that the water then cools down from. After being heated to 38, it cools down to the ambient temperature in the house of 21 degrees Celsius, and we come up with a certain volume in cubic meters, and then you use the conversion in the problem that tells you then how many barrels of water are needed.